Hello friends, welcome back to my YouTube channel Unlock Your Learning. In this video, we are going to solve ICSE Mathematics Class 8 chapter number 6 sets exercise 6a question number 1. State which of the following sets are finite and which are infinite. Okay, we have to tell which of the following sets are finite or infinite. First of all, before starting this, I would like to tell you what is a set, right? A set is a well-defined collection of objects, as we know, right? So basically, in a set, a collection of different objects is done, right? But it is well defined. What does it mean? It means that the elements of the set should not change, right? Let's say I prepare a set, right? Set X, which has all the movies that are good in according to my view, right? I like these movies, so I put them in the set. Will it be the same if I ask it from you? No, it can be different, right? Because the preference of a person can change, right? So that is not well defined. But when we talk about well defined, then it means the value or the elements of the set will remain the same from person to person. Okay, it will not change, it's constant. Let's say I tell you, prepare the set of all the players who have scored 100 in the test match, right? So you can prepare that, right? It's a set data and you can use it to prepare a set. So the value will not change, right? So that is what a set is. Now, what are finite and what are infinite sets, right? If you can count the elements of a set, then that set is a finite set. And if you cannot count, right, the counting never comes to an end, then that set is an infinite set. Okay, if the counting comes to an end, it is a finite set, and if the counting does not come to an end, it is an infinite set. Let's see, the men who have orbited the earth. So is this, first of all, you can see there are braces, right? This is the way of writing set. Okay, you enclose all the things in these braces, curly braces, right? Keep that in mind. So the men who have orbited the earth, what is this? Of course, it is a finite set, right? Why is it a finite set, if I ask you? So you will tell me, we can count the people, right? You can name the people who have orbited the earth. There are a limited number of people who have orbited the earth. That's why this set is finite. It will end after a certain number, right? Then the men who have landed on moon, again it is a finite set. Why? Because again I can count the number of people who have landed on the moon, right? It is countable, right? So what will I say? That this set also is finite. Then the integers between -5 and +5. So what integers lie between -5 and +5? You have -4, you have -3, you have -2, -1, 0, 1, 2, 3, 4, right? That's it. So you can see that after a certain number we have come to an end. Okay, and if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 9 elements in this set, right? So it is what? Countable. That is why this set is a finite set. Yes or no? Yes. Okay, come to the next part. Now, what is this? You can see you may have trouble in reading this set. Why? Because the language is a little different. The method of writing is different. This is in set builder form, right? What have we done here is that basically you can see we have studied this form before also. There are multiple methods, right? Set builder and roster and all that. So here also this is in the set builder form. You read it like this, X, and you can see there is a bar here like this. Some places you will also find a colon. Okay, so both of them, they are read as such that. Okay, keep this in mind. Wherever you find the bar or the colon, you will read it as such that. So X is such that X equal to 2y. Okay, they are giving the characteristic of X, that X is such a number that X is equal to 2 times Y. Okay, then they are saying y belongs to whole number. Okay, you can see one new sign here also, something like this, right? This sign like this means it belongs to, okay, belongs to. So wherever you will find this sign, as you can see here, it means it will be telling you the type of that number. Y belongs to W. W means whole number. W refers to the set of whole numbers. Okay, capital W, wherever you will see, you should understand we are talking about whole numbers. That's why it says Y belongs to whole numbers. So two things it has given us. X is such that X equal to Y and Y belongs to whole numbers. Now you have to tell this set is finite or infinite. So see, do we know how many whole numbers are there? No. We know that whole numbers begin from 0 and they go up till infinity, right? We don't know how many whole numbers are there. So if Y has the value of whole numbers, will Y also have a value that can end? If I give Y 0, so X will become what? 0. Okay, see here, X equals to 2Y, right? So if Y is 0, X will be 2 into 0, so X will be 0. But can it end here? No. I can change the value of Y infinite times. As many whole numbers are there, that many values of Y can be there, and so will the values of X change accordingly, right? So that means the whole number can extend anywhere and the value of Y can extend anywhere. So we cannot count how many elements are there in this set, can we? No, because Y can have infinite values, so that means X will also have infinite values. That's why this set is infinite. Yes or no? Okay, then the fifth part says the infants in your class. You have to tell this is the set of infants in your class. Is it finite or infinite? Of course it is finite. Why? Because this is an empty set. Empty set is that set which has no elements, right? Like this. Okay, this is used to represent an empty set. This sign that you see here that I have made, it is used to represent an empty set. Empty set has no elements. The infants in your class, does your class have any infants? Infants are children below the age of 3. So no, children below the age of 3 are not studying in class 8. That's absolutely wrong. Nobody in your class is of that age. That's why it is an empty set, and therefore this is a finite set, right? Empty set is always finite, right? It has no elements. We can already count how many elements are there. 0 elements. That's why it's a finite set. Let's move on to the next part. Now take a look at the next part, right? It's the sixth part. This says X. Again you can see the colon is coming now. Previously there was a bar sign, so it was read as such that. Now there is a colon sign, so it will also be read as such that only. Okay, X is such that X belongs to real numbers. This sign again, it looks like an E, but it is not an E, right? You all know it. It represents belongs to. Fine. R represents the set of real numbers. Yes, wherever you will find this word, capital R will be given. X belongs to capital R. Okay, so it means that it is a real number. Then 4 is, you can see X is greater than 4 and less than 5. That is given. It is the condition given to you. Fine. We have to tell how many values of X can be there. So basically there is nothing in this part. Okay, they are just saying that you have to tell that how many values of X can be here. If it is a countable value, then then the set that you have, it is finite. If it is uncountable, then it is infinite. Look here, have we studied the property of real numbers? Yes, we have studied real numbers. Okay, the property says that there are infinite number of infinite real numbers between any two real numbers. Okay, look here, if I am talking about 4 and if I am talking about 5, between them there will be infinite numbers. Yes, Okay, uncountable numbers exist, okay, between two numbers. What is x? X is a value between 4 and 5. Okay, so x can be 4.1, x can be 4.12, okay, x can be 4.57, 4.102, and so on. Any value it can have, okay, any value. We don't know which value. And can you count it? See here, only point. If you keep on increasing here, it can go to an endless number of digits. Okay, so it is actually uncountable. Okay, so we have studied it also that between any two numbers exist infinite real numbers. Okay, it's a property. Therefore, what can I say? This set, it is an infinite set. Yes or no? Okay, now see, seventh part is the sets of atoms in the earth. Infinite, of course, very logical way, right? You cannot count how many atoms are there. Even the smallest things, right? Whatever things you see, the table or the chair, they are made up of infinite number of atoms. You can't count them, right? So that's why here also the sets of atoms in the earth, this is an infinite set. Yes or no? Then you see here sets of the multiples of 10. This is infinite. Why? Because 10 can be multiplied to infinity, right? Right now we studied the table of 10, so we do 10 tens, right? It can be 10 into 11 also. It can be 10 into 110 also, so on. It can keep on extending. Okay, there is no limit to that. What are the multiples of 10? We have studied, right? You begin from 10, then you get 20, then you get 30, then so on, you go till 100, then 110, 120, so on. It keeps on extending, it doesn't end. That's why this set is infinite. Yes or no? Then the ninth part of this says the sets of points on a line segment. Again, we have studied this property also. If A, B is a line segment, so infinite number of points can be plotted on this line segment, right? There is no limit. You can see it will not end. You can point and plot out infinite points here like this. Simple property it is. That's why this is also an infinite set. Okay, 10th part says the sets of grains of sand in a small bottle, right? Very simple. Okay, this is a finite set, right? If we are talking about a small bottle, right, we can count it very easily. Okay, although it doesn't match, but still this is what's given in the book, right? And if you're talking about a small bottle, it's possible that we can count the sets of grains in it, right? And friends, this is all for today. If you are new to my YouTube channel, do not forget to subscribe and leave a like on this one. Till then, take good care of yourselves and bye.